Lesson 4-7, Graphs of other trigonometric functions. Alright, our first other trig function is tangent. Tangent looks a little bit different, but it is still periodic. That pattern repeats. Notice though it repeats every pi. We're going up through the x-axis, going up to the x-axis at pi later. So instead of 2 pi for tangent, the period is 1 pi. So our period would be pi over b. And we have asymptotes everywhere where tangent is undefined, which is pi over 2 and 3 pi over 2, and so on. For y equals cotangent of x, it looks like tangent but flipped upside down. It is also shifted sideways. The period, though, is still pi. From there to there, where it repeats is pi. So it's pi over b to calculate the period. Now the asymptotes where cotangent is undefined, which is 0, pi, 2 pi, so on. Alright, to graph y equals tangent of x over 4, this would be like tangent of 1/4 x. So b would be 1/4, which changes our period. The period was pi over b, so now it's pi over a 4th. Well, multiply by the reciprocal, and you see that our period will be 4 pi. So I'm just going to count over. And 1, 2, 3, 4. So let's make that 4 pi, 2 pi, 1, 2, 3. All right. So for tangent, it goes through 0, 0. And so then at the period, it's going to go through 0, 0 again. So at 4 pi, it's going through 0, 0 again. The asymptote is halfway in between those. And so that was 2 spaces away from my 0, 0. So the other asymptote on the other side will also be 2 spaces away. And we do have something like an amplitude. The amplitude in this case is just 1. Which means 1 space over, we're at our amplitude. So you go near the asymptote, go through the amplitude, and you intercept, and then you go near the other asymptote. Then just repeat the pattern. Just repeat the pattern. There's another asymptote there. Something like that. Cosecant is the reciprocal of sine. So this actually works out as if you graph the sine first, cosecant makes these weird little loops above and below sine where they touch at the maximums and the minimums. Since it's with sine, the period is 2 pi. And we have the asymptotes where sine equals 0, because then the reciprocal is 1 over 0 or undefined. So that means we have asymptotes at all the x-axis, or x-intercepts, of sine. So it'll be 0, pi, and 2 pi. Secant is very similar to cosecant. In fact, they're just shifted from each other. Only this one uses cosine instead of sine, because secant is the reciprocal of cosine. But it's the same idea. We can draw cosine, and then you draw the asymptotes, where cosine equals 0, where the x-intercepts for cosine are. And then you do these nice little loops. The asymptotes would be at pi over 2, 3 pi over 2, etc. So let's graph 2 cosecant of x plus pi over 2. Well, that's an A, B is 1, C is negative pi over 2. So I know the amplitude is 2. The B is 1, so that doesn't do anything. C is negative pi over 2. That's our phase shift. Phase shift is C over B. So it's negative pi over 2 over 1, or negative pi over 2. So we're shifting pi over 2 to the left since it's negative, since the C was negative. Our period is still 2 pi, so I'll go 4 spaces over, put my period. All right, and let's start by graphing. Since it's cosecant, we'll graph sine. So sine starts at 0. Oh, but I'm shifted pi over 2 to the left, so it's actually there. And then at 2 pi, oh, but I'm shifted pi over 2 to the left. Halfway in between is the other x-intercept. Half between those are the amplitudes, so 2 and negative 2. So it's going to go up, down. Now, probably ought to make this dotted, because it's actually not the graph we want. Follow the pattern. Now we're going to put asymptotes at all the x-intercepts. 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 And then we just draw these nice little loopies. Start near the asymptote, go down, hit the graph of sine. Need the one on the edge too. It's only half there. Oops. And do the best little loopies you can. And there you go. The graph is the little loops at the top and the bottom. We also have what are called damped trig functions that we can graph. Or something like this, where x, it could be any function, and its times are trig function. So it's a function times a trig function. That x is called the damping function. So what we do is we graph the damping function and its reflection over the x-axis. And then the trig function goes between, because this is also the amplitude. So our damping function is the amplitude. So here is x sine of x. So our damping function is y equals x, and its reflection over the x-axis, y equals negative x. It's sine, so we start at 0 and hit the period at 2 pi. The other x-intercept's halfway in between. Now the maximum and the minimum are there, so that's where it touches the damping function, and you can see we just draw it to those points. Now on the other side it goes back up, and that's because now the x is negative on the left, which means the amplitude is negative on the left, so it means it's upside down on the left. This is often done with exponential decay, so you'll have it going up and down and up and down. and levels off like a pendulum swinging back and forth, or something like that.